Hey guys, today I will show you how to evaluate numbers with decimal recurring powers or exponents. And all that means that your power, your exponent, that your base number basically raised, happens to be is a decimal, but infinite decimal. So the number of digits after a point repeats itself. So there is a pattern of these digits that repeats itself. Now, first of all, let's convert this base into an improper fraction. So your base happens to be as a mixed number, so let's convert it into an improper fraction. So 3 times 8 gives you 24 plus 3 gives you 27 over 8. The reason why I did this, because eventually when I convert this power into a root, into a radical form, eventually I'm going to take a root of that base. So it's better that we prepared our base. And we can take a root, any root of the base. If your base as a fraction. Now, 0.3 recurring, so 0.3 recurring, that basically this notation 0.3, and it's like the small bar up on this digit 3, that indicates that 3 repeats itself. So basically this notation stands for 0.3333, keep going on forever, never stop. So that's basically a shortcut. Sometimes it's written with a small dot on top, so sometimes you might see this notation. It's precisely the same. So dot or a small bar up the digit indicates that the digit, or sometimes it's more than one digit, it could be a group of digits, they repeat itself infinite number of times. So the following thing to do is you want to convert this decimal into a fraction. So it's very similar to evaluating numbers with decimal exponents or decimal powers. And by the way, I have a tons of videos, and it's kind of serious. So how to evaluate numbers with fractional powers, with negative fractional exponents, with decimal exponents, with negative decimal exponents, and all these links would be down below in the description box. And if you're up to more examples and more explanations, definitely check them out. Now, you need to convert it into a fraction, and it happens to be just a third. So there is a special technique to convert it, but it's kind of obvious. So since 1 over 3, if you basically punch it into your calculator, and if you divide 1 over 3, or you could do it basically by your hand off to the side, so you end up getting something like 0.33333. Anyway, that this decimal recurring fraction means just a third if you write it and convert it into a normal fraction. Alright, now things getting better. So since we have a fractional power, as a good rule of thumb, convert it into a radical form, and I'm going to use the second property. So all that means that the fractional power, the bottom of the fractional power, takes a root of this base number, and the top number n raises to whatever you get over here. So let's convert it. So again, bottom number takes a root of whatever you are given. So your base happens to be as a fraction, so you have to keep it. And basically this thing has to be raised to the first power. But since it's a first power, so basically, technically, it's like this. But normally we don't write the first power, because any number raised, just recall that any number raised to the first power gives you the same number, precisely the same. So at this point, this first power can be just ignored and omitted, neglected. So all you need to do is just evaluate this cube root of 27/8, and the way you do, recall that you have to split it, just the cube root of top over the cube root of bottom. So this entire cube root can be broken down, can be split up into two separate roots. And just ask yourself what number has to be multiplied by itself to produce this 27. And the answer is 3, since 3 times 3 times 3 gives you back this 27. So your top becomes 3. And the similar goes for bottom. Ask yourself what number has to be multiplied by itself to obtain 8. And the answer is 3, since the answer is 2, Lord. Since 2 times 2 times 2 gives you back this 8. So 3/2. And if you like to convert it, since your top number is greater, is bigger than bottom number, so if you are asked, if you are required, if your book requires, or if your teacher asks you, or if you just would like to do that, so feel free to convert it into a mixed number. So 2 goes into 3 ones, leaving you a half. So both answers are perfectly fine, and that's your evaluation, that's your value for that fraction. Alright, now say you have been asked to evaluate this number. Looks spooky even for me. Anyway, let's first of all convert this. So basically you are given, look at this, you are given your base is a decimal number and your power is a negative recurring decimal. All these scary things, they come together. Let's just get rid of them. Alright, so let's first of all convert the base into a fraction. So 0.001, it's 1/1000. Let's start off with this. And by the way, to be perfectly frank with you, you could do these things like you could literally change the steps. I mean, it's all about how it clicks to your brain. I mean, you could start with power and convert it, and after you could come to the base. Even like here, so you could start with the power and converting it to the fraction, and after you could change your base into a fraction. So again, there is no right way of doing like at the beginning. So you could basically swap and change things up, I mean steps. So it's completely, totally up to your whim and how your brain works at this point. Now, anyway, it's kind of my disclaimer. Anyway, 0.3 recurring. So I'm going to rewrite it as a normal fraction. So like we already discussed it before. So you keep this negative and 0.3 recurring. So it's basically a third power. It's 1/3. Now, I think that you should always keep in mind how to deal with negative powers. And the thing is, anytime when you come across a negative power, it can be turned into a positive power by taking the reciprocal. So it's here where this rule kicks in. So the negative power indicates the reciprocation. So you want to take the reciprocal of the base. So 1 over this base A, any base what you are given, raised to positive power. So your power k becomes positive power. So let's do it. And look, since your base number happens to be as a fraction, so the reciprocation at this point means that you need to swap, you need to change, you need to switch your top and bottom. And instead of 1/1000, your base becomes just 1000 and your power becomes positive. Again, treat your power as a like entire fraction. Do not tear it apart, do not split it up. So your power has to be taken as a whole entire thing. Now we got rid of this negative power, and now we are almost there, we are almost done. So at this point you want to get rid of this fractional power, and you want to convert it and turn it into a radical form. So again, what this fractional power means, all it does is just your bottom number takes a root of this base, and your top number one raises to this power. So it's basically similar to what we did for the first example. So it becomes the cube root of 1000 raised to the first power. So I'm not going to write it at this point. So again, anything raised to the first power leaves you the same thing, the same base, the same number. So it could be neglected, omitted, and ignored at this point. And all you need to do is just evaluate this root. So cube root of 1000, so it evaluates to 10, since 10 times 10 times 10 gives you that 1000. So it comes out to be just 10. So that's your evaluation, that's your value for that second one. Alright, with this being said, huge thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please hit this like, share with your friends, leave the comments down below. Be sure to smash that subscribe button, so if you haven't, so you'll not miss out my new videos.